Ever asked your phone a question or seen a car drive itself? That's not magic, it's neural networks, a kind of artificial intelligence inspired by our own brains. These invisible engines power everything from search engines to movie recommendations, shaping our daily lives. Don't worry, we'll explore how they work using simple ideas and real-life examples. No scary math required. Neural networks are modeled after the human brain's billions of interconnected neurons, letting computers learn, adapt, and make decisions. By the end, you'll understand what's really happening when your smart speaker answers you or your phone recognizes a face. Let's dive in. Imagine a neuron as a tiny messenger, passing signals along if the message is strong enough. Artificial neurons work like light switches. Each one flips on only if enough others send power. Alone, a switch can't do much, but connect thousands in layers and you get a neural network. The first layer might scan pixels in a photo, the next finds patterns like lines or curves, and deeper layers combine those into shapes, like an eye or a nose. Eventually the network recognizes complex things, like a face or a cat, by building up from simple patterns. No single switch is smart, but together, they solve problems that seem almost magical. That's the power of teamwork, digital style. So how does a neural network learn to tell a cat from a dog? At first it's clueless, a blank slate making random guesses. We train it by showing thousands of labeled images. Each time it guesses wrong, we correct it. With every mistake, the network tweaks its internal connections, learning a little more each time. It's not memorizing rules like cats have pointy ears. It's recognizing subtle patterns in the data. Through repetition, it gradually gets better, just like we learn by trial and error. The network doesn't understand cats or dogs, it just gets really good at matching patterns. Over time, it becomes an expert at its task, all through practice and feedback. That's how digital brains learn, by trying, failing, and adjusting until they get it right. The learning process is called backpropagation. Think of it as a blame game in reverse. When the network makes a mistake, the error signal travels backward, nudging the most responsible connections to adjust. It's like a coach telling a rowing team to steer right after drifting off course. Each rower tweaks their effort. This cycle of guessing, correcting, and adjusting lets the network learn without explicit instructions. Instead of hard-coded rules, it discovers patterns on its own, becoming flexible and adaptable. Over millions of corrections, the network fine-tunes itself, strengthening good connections and weakening bad ones. In the end, it's a master pattern matcher, powerful, but not truly thinking like a human. Neural networks are impressive, but they have real limitations. They don't understand what they're doing, they just spot patterns in data. Their decision-making is often a black box, making it hard for humans to see why they chose an answer. If the training data is biased, the network will be biased too. Garbage in, garbage out. Small changes in input can fool them, showing how fragile their understanding really is. These tools are powerful, but not infallible. We must use them with caution and critical thinking. Trust, transparency, and fairness are essential as we rely more on these digital brains. Neural networks are everywhere, in your phone, your home, and even your car. Voice assistants use them to turn speech into text and understand your requests. Social media uses them to recognize faces and organize your photos. Language models like ChatGPT generate text, answer questions, and help us write. Self-driving cars rely on networks to see the road, spot obstacles, and make split-second decisions. These systems work together behind the scenes, making technology smarter and more helpful. Neural networks are transforming how we interact with information and the world. Their impact is only growing. Neural networks are powerful tools, but they're not magic. They don't have intentions or common sense. It's up to us to use them responsibly, ensuring the data is fair and the systems are transparent. We need to question, understand, and hold these systems accountable, especially when decisions affect people's lives. Learning the basics of how they work helps us ask better questions and spot potential problems. Stay curious, keep learning, and be part of the conversation about how AI shapes our future. By understanding these digital brains, we can help build a smarter, fairer world. Thanks for joining this journey into the science behind the invisible brains all around us. Please subscribe.